Hi, and welcome to the third episode in a series on doing creative things with sound in the browser using p5.js. In this video, we're going to explore sound manipulation and learn how to use functions such as setVolume, pan, and rate in combination with visual elements on screen. A simple way to manipulate a sound file is to change its volume. We'll take this process a step further by writing a program that lets us connect the volume of a sound to the size of a visual element in the browser. We'll also use audio panning across the left and right channels as a way of controlling the movement of this visual element. We'll learn how to slow down a sound as a way of creating an interesting soundscape. First of all, we need an audio file. I'm going to use an MP3 file of some birdsong. I load the sound into memory by declaring a variable and assigning the sound to that variable. And I do this inside of a preload function. In a minute, I'm going to add a button that I can click to play the sound. But in order to add anything to the screen, I need to define an area in the browser where my sketch will be displayed. I can do this by creating a canvas using the function createCanvas. I'll make the canvas the size of the browser window using the variables window width and window height. These are system variables that are part of the p5.js library. The code for the canvas goes inside setup. I'm also going to give the canvas a blue background, but that will go in draw. Okay, now I've got my canvas, I can go ahead and create a playback button. In p5.js, we can do that by assigning a button to a variable, just like we do with a sound file. First, the variable. Next, in setup, I write the createButton function to initialize the playButton variable as a button. I also write in quotation marks what I want to display on the button inside the parentheses. Now, let's position this button in the top left corner with a margin of 25 pixels from the left and 35 pixels from the top. We can call the position method on the button variable. In p5.js, the default origin of the axis is the top left corner, so I'm shifting the button 25 pixels along the x-axis to the right and 35 pixels along the y-axis downwards. I need to write another line that tells the computer what to do when someone clicks the button, so I call the mouse press method on the button. To recap, we've initialized a variable called playButton as a button using the createButton function. We've labeled the button with the word play by putting this word in quotation marks inside the parentheses. We've done all this in setup. We've called the mouse press method on the button variable, but if we click the button, nothing happens. This is because we still need to write the code that tells the browser what to do when the button is clicked. I've put the word start inside the parentheses of the mouse press method. I'm now going to write a function called start with code that runs when the mouse is clicked. This bespoke function is designed to start the playback of the sound, so it calls the play method on the birdsong variable. It performs an action on that variable by playing the sound file currently assigned to that variable. Now, if I run the program again, we should hear a sound. One other thing, I want to make sure that if I accidentally click the play button again while the sound is playing, the sound restarts rather than starting another additional and layered playback of the file. I can control what happens when someone clicks play when the sound is already playing by calling the playmode method on the birdsong variable. This method is part of the p5.sound library. If you look up playmode in the p5 reference, you'll see you can set up playback to restart by passing the argument restart. We can do this in setup. Let's recap. When we click the mouse on the play button, the browser calls the mouse press method and runs the lines of code contained within the start function. Okay, let's follow the same logic and add a volume slider. First, the variable. Now create the slider and position it on the screen. Creating a volume slider is basically the same as creating a button, except that we use the createSlider function. Previously, we put text in between the parentheses of the createButton function. For the createSlider function, we write numbers as arguments. So we should take a look at what these numbers mean. We see that it takes 4 parameters, 2 of which are optional: min, minimum value of the slider; max, or maximum value of the slider; default value of the slider, which is optional; and step size for each tick of the slider, which is also optional. In our sketch, we've set the volume slider to have a minimum value of 0 and a maximum value of 1, with a default value of 0.5 and a step size of continuous. But in order that the volume slider actually affects the volume of the sound file while it's playing back, we need to assign the current value of the slider at any particular moment in time to the volume of the sound at that particular moment in time. Let's write this out in pseudocode. 1. Constantly check the current value of the slider and report its value on a scale of 0 to 1. 2. Immediately assign this current value to the volume of the sound that's playing back. We can get the current value of the slider by calling the value method on the volSlider variable, and we can assign that value to the volume of the sound by passing it as an argument to the setVolume method, which we call on the birdsong variable. Now, let's connect the value of the volume slider to the size of a circle on screen. First, I'm going to draw a circle using the ellipse function in p5.js. I will need a variable for its size. Now I can easily assign the volume of the sound to this variable using the value method. I want to draw the circle in the center of the screen, so I can use the window width and window height variables and divide each in half. The parameters which I pass to ellipse are x coordinate, y coordinate, width and height. In order to see this circle, I'll need to give it a color. I'll make it orange. But at the moment it's a tiny circle because the width and height are the same as the current value of the volume slider, which is somewhere between 0 and 1. To make the circle larger than 1 pixel, I need to multiply this volume value by a constant, let's say 400. Okay, now we can see it. When we raise the volume, the circle gets bigger, which simulates the effect of an object getting nearer to us, and it gets smaller when we lower the volume as if it were moving away. In p5.js, the fill function can take a fourth value, which is opacity, in addition to the 3 red, green and blue values. But instead of putting in a number, let's set the opacity as a variable and update that variable with the volume value. Here I've multiplied volSlider.value by 255, which maps the volume value originally between 0 and 1 to the opacity scale, which is between 0 and 255. Now all I need to do is add this opacity functionality to the fill function. Also, to help with the disappearance of the circle into the background, let's turn off the default outline feature using no stroke. The change in size of the circle combined with the change in opacity, both of which are controlled by the change in volume, now gives a convincing effect of an object moving towards and away from us.
What we've done here is manipulated sound and image at the same time. We've used the facility of digital code to make an audiovisual composition where what we see and what we hear are controlled by the same data. We can go further by panning sound across the left and right audio channels and mapping the panning value to the horizontal position of the circle on the screen.
First, the variable, and second, in setup, the arguments for the pan slider here are arranged from -1 or fully left to 1 fully right, initial value of 0 or in the middle, and a continuous step movement. Earlier we called the value method on the volume variable to get a value we could use to set the volume of the sound and also to set the opacity and size of a circle. In the same way, we'll call the value method for the pan slider variable to get the current slider value and pass this to the pan method on the birdsong variable. Let's try it in the browser. Now, let's map the same pan value to control the x-coordinate of the circle on screen. We do this in draw. These lines need a little explanation. This line declares the variable circle position and initializes it using a p5 function called map. This is a very useful function that maps a value from one range to another. This line is straightforward. I just replace the x-coordinate or first parameter of the ellipse function with the variable circle position. I want to use the pan value to control the x-coordinate of the circle while keeping the y-coordinate constant, so I need to convert a value from a range of -1 to 1 to a range of 0 to the width of the window. The P5 reference tells us that map requires the value to be mapped and the minimum and maximum values of both the input and output ranges. So I put panSlider.value in as the value to be mapped, then put in the minimum and maximum values of the panning range, -1 to 1, and then the minimum and maximum values of the x-coordinate, 0, and the width of the window. But there's a catch. When we run this, we see that the circle now goes off the screen on either side. Don't fear, we can fix this by adding and subtracting half the width of the circle from the second range of values. To get the value for half the width of the circle, I just divide circle size by 2. Now, let's give the user the option of slowing down the birdsong using the rate method. If we look this up in the reference and scroll down, we can see the parameters that go between the parentheses. 1 is normal, 0.5 is half speed, and 2 is twice as fast. Values less than 0 play backwards. Let's create a slider for playback speed. And now let's pass the value of the playback slider to the rate method for the birdsong variable. Let's try it in the browser. The only thing left to do now is to make the control interface a little more user-friendly by adding text labels. We can do this with the text function in p5.js. The values are trial and error according to layout preference.
If you found this video useful, please consider subscribing to this channel, and I'll see you in the next episode.